Hello and welcome in. Mark here, aka the Markster. This is video number 13 in the FreeCAD series. Today we're going to begin working with the sketch workbench, the Sketcher workbench. You can use the Sketcher to create two-dimensional sketches, which you can use with these extrude, revolve, loft, and sweep tools to create solid objects. Let me show you which version of FreeCAD I'm using today. 0.19, revision number 19510. So this is the first model that we made in video 1. A simple pipe. This is that file. And we made it using a cut between two cylinders. And today we're going to redo this model using sketch-based modeling strategy. So let me close this file, create a new file. Since we already have the spreadsheet in that other file, and we're not going to change that, one option we have is to merge this project. We can choose that file, bring it in, and since we don't need to cut, let me just leave it in and hide it. And we'll save this and call it pipe 2. By hiding it, we'll be able to show the difference between the two finished products. Just to review what the spreadsheet looks like, we have the length, which was 4.5 inches. The internal diameter of 1 inch and the wall thickness of 1/8 inch. Let's go to the Sketcher, create a new sketch. Cannot map the sketch to selected object, broken link to support sub elements. The problem I have here is I had the spreadsheet selected when I created the new sketch, and you cannot map to a spreadsheet because it's not a 3D object. So we need to make sure nothing is selected. We can do that by just clicking in open space and do it again. And now we have sketch orientation. Notice the XY plane, it shows the area shaded that would be on that plane. The XZ is the front, the XY is the top or the bottom. You can think of it either way. XZ would be the front or the back, and YZ would be the left or the right. So we're going to put this one on the XY plane because we're going to create a sketch with two circles, one inside the other, to represent the internal and external diameters, and then we'll just pad that sketch. So now we are in the Sketcher. Let's take a little bit of a tour. Here on the left side in the task dialog, we have solver messages. Messages will appear here. So you always want to keep an eye on this section. If there is an error or a warning or just some information, it'll appear here. Auto remove redundants. is an option that I like to have enabled. It removes redundant constraints. We'll talk a little bit more about constraints in a moment. Auto update option. If this is enabled, your model gets recomputed each time you make a change, which is going to slow things down. You don't need that. You can leave that unchecked. When you close your sketch, it'll do the update then, or you can trigger an update by clicking this button. You will not see advanced solver control. This is something I had to enable. Go into the settings and enable this. It's not something you need to worry about right now. The edit controls panel. You can show a grid in the sketcher. It's 10 millimeters apart each line. You can enable grid snapping so that if you draw an element, for example, a line segment here, it'll snap to the nearest point in there. You see how that one did? And when I get close to this corner, you see how it snaps to it. This can be convenient at times. I right click to get out of that mode, but it can also be problematic because you really need to constrain the ends of line segments together and not just have them in the same location. We have a constraint right here called the coincident constraint, which will force those two end segments together. So this can create a false sense that your sketch is connected when it really isn't. So I do not recommend using this. You can use the grid as a reference if you like. I prefer not having it. To me, it just clutters up the view. Auto constraints is a way to add a constraint. For example, I could constrain this line segment. Notice to the lower right corner of the cursor, that coincident constraint icon appears. I can automatically constrain this during the object creation rather than, that was a right click to get out of that mode, rather than drawing my line and then constraining it later, which I could also do. Coincident constraint to this origin. Having auto constraints enabled it just improves your productivity by allowing you to create your constraints while you are adding your elements. I'm going to hit delete to delete this line segment. Avoid redundant auto constraints. Redundant constraints would be two constraints that are constraining an element to be basically the same thing. And this will avoid adding a new constraint if it's just a redundant constraint. You don't want redundant constraints. One example might be the position of an endpoint of a line and the length of that line. If you got both ends of the line constrained with coincident constraints, then the line length might in many cases be a redundant constraint. So this avoids those automatic constraints that would be redundant. This would be a list of your constraints, which we have none yet, and this will be a list of your elements. So the elements can include points, line segments, arcs, circles, ellipses. This is a B-spline. And these are tools that just create line segments and connect them together. So we'll get into all these tools as we move along. So that's the dialog here. As I mentioned already, these are your elements. These are some tools for dealing with those elements. This is a tool that you can use to create a link to something external to the sketch. And we'll definitely talk about all these options here, probably in later videos. These are your constraints. This is the coincident constraint, which we showed a moment ago, constrains two endpoints or 2 points to the same location. This would constrain a point to the edge of an object. For example, you could have a line segment here, and you see that constraint comes up. So now this endpoint of this line is constrained to this line, and it will always be on that line, although it need not be on the line. It's on the extension of the line. Of course, this is a line segment, and a line extends to infinity in both directions. Let me delete these. This is a vertical constraint, horizontal. This is a parallel constraint. It would constrain 2 line segments to be parallel to one another. My voice is drying out with all these allergies. This is a perpendicular constraint, a tangent, equality, symmetry, a block constraint. Again, we'll talk about all of these. The lock. This is a horizontal distance constraint, vertical, a line length constraint. This is a diameter, but we can constrain by diameter or radius, arcs and circles. This is an angle constraint. This tool here toggles between reference mode and normal mode. You can have a reference mode constraint that just shows you the length of the line, for example, and this would actually disable a constraint. Right click to get out of that. Okay, so what we're going to do today, now that we've finished our little tour, we're going to create 2 circles using this tool here. With the circle, you have actually 2 ways to create circles. If you have 3 points already on your sketch, you could use this method. But since we don't have any yet, we'll use the center and rim point method. So we can constrain the center of our circle automatically right here, or we can constrain it afterwards. We want it centered. Generally, you want your sketches centered about the origin. Select both points. Select the coincident constraint. Let me undo that to show you something. You can always undo. If something goes wrong, don't panic. Undo the last step. Sometimes you can add a constraint and your whole sketch just changes in some unpredictable way that you were not expecting. Just undo it. Try to figure out what went wrong. So here in the solver messages, we have under constrained sketch with 3 degrees of freedom. Every element that you add to your sketch adds degrees of freedom. Try to drink a bit of water. so my voice is not so raspy. The circle adds 3 degrees of freedom. 1 degree would be the x coordinate of the center of the circle. Another would be the y coordinate. And the third would be the radius or diameter of the circle. So by constraining the center of our circle to the origin, we're eliminating 2 of those degrees of freedom. We want 0 degrees of freedom. That's our goal. This would be a fully constrained sketch. You do not want too many constraints. That would be an over-constrained sketch, which is worse than an under-constrained sketch. So now we can set our radius. Actually, we'll set diameter, since in this particular case we're using a diameter, and we can reference our spreadsheet just like before. You can give your constraint a name if you like, and reference that constraint outside of the sketch. We do not need a name in this particular case. So this is our internal diameter. And if we look down here in our constraints, we see the coincidence and the diameter. And we can rename from here as well. Press escape. And in the elements, we see that we have the 1 circle element. Sometimes it can be a challenge to select an element in the 3D view. You might have several elements overlapping. You can select from here. Honestly, I'm not sure what exactly these are. Another thing to point out, control multiple selection. Inside the sketcher, it has something called greedy selection. You do not need to press control to select multiple objects at once. That's while you're working inside the sketch editor. When you're outside the sketch editor, you still need to use the control key. It's just a way to be a little bit more productive. So we need another circle now. This is our internal diameter. We need a larger one. And we can add it here. You see I automatically added the coincident constraint for the middle of the second circle. And by the way, you can also move around these constraints, sort of get them out the way. And we'll constrain the diameter of this as the ID plus wall. I believe that would be correct. Wall thickness here. Is that correct? I do need to double that. Might need to double that. Let's close this. It's a good time to show the measuring tool in the part workbench. We haven't used that yet. You may have noticed that we have some tape measures here. We can select 2 points and measure the distance between them with the measuring tool. So it is 1.58 millimeters apart. That is our wall thickness, which is half of what we need for our wall thickness. So we did need to multiply that by 2. So let's open the sketch back up and let's modify this formula. Wall thickness times 2. That's our diameter that we need. Close the sketch. Notice that the measurement that we made, it did not extend when we made this outer circle larger. But there is a toolbar icon here. This is new for 0.19. We can refresh this and it will recompute that measurement. So now we're getting the wall thickness that we want. And we can clear this, clear all, to get rid of that annotation. Now we're ready to extrude our sketch. With the extrude operation, we cannot access the expression engine from within the extrude dialog. So let's just do it first and then we'll change it in the properties. Switch to the data tab if you're not already in it, as I wasn't. And the length forward here will be the length. And F5 to recompute. So this is our extruded sketch version of the pipe. We can unhide the cut to show that it is in fact the same size and proportion. That would have also shown us perhaps that we had the wrong formula for the outer diameter at first. Let's save it. You remember the last video, I neglected to save before running a check geometry and it cost me some work. So we have no errors. So our model is good. Now there's also another way to create the same object using the revolve tool. Let's go back to the sketcher, create a sketch. You select the method to attach the sketch to selected object. So I had the extrude object still selected. I do not want to attach this sketch to that object, so I'm going to cancel. Click somewhere to deselect all of these and do this again. This time we're going to revolve a sketch, and I want this sketch on the XZ plane. Notice we still have the X and Y axis. The sketcher is a two-dimensional tool. In some CAD packages, not FreeCAD, but in other CAD programs, you can create three-dimensional sketches. But in FreeCAD, we only have two-dimensional sketches. Every sketch, even though this one is on the XZ plane, this is still the X and the Y coordinates that we're using, not the Z. In reality, this is the Z axis, but as far as the sketch is concerned internally, it's all x and y. Z equals 0 in all cases. So within the local coordinate system inside the sketch, we only work with x and y. So what we need for this profile is a rectangle. We're going to draw the rectangle here to the right. We have two options here. We could center the rectangle around the origin and then move the sketch out to the radius that we need. Or we could put the elements away from the origin to create that radius that we need. We're going to be revolving this around this Z axis to create our tube. So we have those two options. I'm going to choose the option of putting it off here to the right. So we need the height of our, notice we automatically have the vertical constraints. We have 4 degrees of freedom. And we're going to set the height of our tube, the length of our tube here, with the vertical constraint. Click the FX icon, ss.ss. This will be our length. And the wall thickness will be this one, the horizontal constraint. Hope I'm not going too fast for you. Notice we have 2 degrees remaining. And the wall thickness here. This is the side profile. We can move these constraints so that they're not in our way. Now we need to have the radius, which is from the inner wall. Always select a point. And the origin, that distance is our radius. And that's going to be the diameter divided by 2. And we have 1 degree of freedom. And that degree of freedom is the position of our rectangle relative to the the x-axis. What I'm going to do is select these 2 points plus the x-axis and apply the symmetry constraint. The symmetry constraint will ensure that the line is evenly centered vertically relative to the horizontal axis. Notice we're now at fully constrained sketch. Our line color has changed from white to this vibrant lime color as an indicator that we are now fully constrained. We'll close the sketch. We go to the part workbench. As view from the top. That's the view from the top. Or we can view from the front as well. Remember, we are on the XZ plane. So now the top view is just this part. Let me tilt slightly. So we're going to rotate or revolve our sketch. Select the sketch. Click the revolve tool. By default, we revolve around the z-axis, which is what we want in this case. 360 degrees, a full revolution. And we want to create a solid. We say OK. And now we have our tube. And we can compare it to the original two cylinders. Notice that we are in a different location now because we centered our sketch relative to the horizontal coordinate. Aside from that, it's identical. We could have lined it up to the y-axis. Let's go back into the sketch. If you would like to do that, notice the list of constraints. The last constraint was the symmetry constraint. We can delete that. Right click and delete, or just press the delete key. And what happened here? Oh, you know what it was? When we added the symmetry constraint, it deleted the vertical constraint because that became redundant. When we had this, where is it at? Automatically remove redundance. It removed automatically this vertical constraint that was on this line, because it would have been redundant, because the symmetry implies verticality in the way that we've applied it here, at least. So we would need to reapply the vertical constraint to this edge. And now we have 1 degree of freedom. And the way we could line this up, if we wanted to, on the horizontal axis, select the axis, select the point, and choose the fixed point onto object. And now we're lined up where the other cut object was. This is not necessary, but if we had a model that involved needing this to be in this location, then that would be the way to do that. So that is the revolve and the extrude techniques of creating that pipe object. We can also use sketches with the loft utility and the sweep utility, but unfortunately there is a limitation, and this video is already over 30 minutes, and I want to keep these videos in that 30-minute range or less. So maybe we'll cover these two operations later, perhaps in the next video, making the same model. The limitation with these two tools when it comes to using sketches is you cannot have an inner wire. So we have the two circles, one inside the other. You cannot use an inner wire with either of these tools. We could sweep our sketch that we use for the revolve, sweep it on a circle, using the circle as the path. In fact, I think we could do that right now. Just run a little long. I don't think the manager will mind. Where are we at here? Let's duplicate this sketch. Edit, duplicate selection. When you duplicate a sketch that is dependent upon another object, you have the option here of duplicating the sketch and the object it is depending on, which is the spreadsheet, but we don't want two spreadsheets, so we can deselect that, press OK, and then we have another sketch. We could have used the same sketch. Either way, that would work too. Now let's create a new sketch containing our circle. This one would be on the XY plane. And we'll make a circle. Put it here. On the grid freedom, we have it coincident constraint set already. And we can constrain our diameter to be, let's see, equals the internal diameter. Let's see, it lines up well. I'll close the sketch. Back to part. And there's no need to map the sketch to the circle. It's already on the circle. I haven't tried this yet. Hopefully it'll work. Let's choose the sweep tool. And sketch 2 is the profile. Sweep path. We select it in the 3D view. That's the circle. Done. Create a solid. Let's try Frenit mode. So we have swept around the circle. You would use the revolve tool in this case instead of going through this trouble. But if you wanted an elliptical path, then you could use an ellipse instead of a circle, which would be not something that the revolve tool would support. Well, that's going to be it for today. We ran a little bit over long with 38 minutes or so, but we covered reproducing this pipe model using sketches in the part workbench. We showed how to do it using an extrude tool, a revolve tool, and a sweep tool. The loft tool would be a little bit more involved to do because of that limitation of not being able to have a sketch with an internal and an external wire, it's called. The way to do it is create one sketch for you inside, another sketch for the outside, and at the bottom the same. So you would have 4 sketches as a workaround. You would loft between the 2 inside sketches, loft between the 2 outside sketches, and then do a Boolean cut to cut out the middle. So that's all there is to that. It's just not nearly as convenient. To be able to have a single sketch to extrude is much easier than fighting with the loft for this. Of course, if you're making something like a funnel, then perhaps it would be worth the trouble. But more likely, the revolve is a tool to use for that. We'll probably do the funnel again also that we did. I think it was in video 2. So that's going to be it for today. I thank you for watching, and as always, have a great day.